Can you see my screen now?
Yes.
We will use Price parity hypothesis as an example. Okay. For the second question, we'll use this document PPP. Okay. PPP. Okay. This is monthly data. I will also introduce PPP. Purchasing power parity. If we express this hypothesis into algebra, it should be spot exchange rate equal to domestic price divided by foreign price. Okay, ST here denote spot exchange rate, PT denote the domestic price. Okay, PT star denote the foreign price. Okay, foreign price. Okay. After we can take natural log of this equation for both left-hand side, right-hand side. We can get this expression. Right? After we take natural log, we get log spot rate equal to log PT minus log PT star. Right? After taking the natural log. In other words, in this equation, we have 3 time series. Okay, we are going to test the long-run relationship of these 3 time series. In other words, this is just an application of Johansen approach, right? So for this data, we will use these 3 columns. Okay, the first one is a natural log of price index of Italy. The second one is a natural log of price index of France. This one, log x, is spot exchange rate. Okay, is a natural log of spot exchange rate. So we are going to construct a VAR model. In the PCB, the VAR model should use also the model for time series data. However, the model class should be multiple equation dynamic modeling. Multiple equation means you estimate the result of multiple equations simultaneously. In other words, it includes several multiple dependent variables. Okay. In other words, it's a model for vector autoregressive or vector error correction model, right? We should, for Johansen test, we should use a multiple equation dynamic modeling, right? We add the 3 time series. The log x, log Italy, and log France. Okay, but how many lag terms we should add in the equation? Okay, how many lag terms? In fact, when we talk about the augmented differential test, we also counter with the problem: how many lag terms we should add the equation? I've told you initially we should adjust the lag term based on the frequency of data. It's monthly data. We try 12, and after run all the regression, we can get the AIC. Information criteria, AIC, BIC. We use information criteria to choose the optimal specification, right? So in this case, we try 12. However, here I should say more lag terms add into the equation. It will render it will make the power of test lower. Okay, it will lower the power of test. If you only add too few lag terms into the regression, you'll find the null hypothesis is very easily to be rejected. So you should choose the optimal specification. Okay, since it's monthly data, we use 12 lag terms, right? We add log x, log Italy, log France. Okay. Before the constant, there is a u. What does it mean? It's unrestricted constant. The unrestricted constant in this case, it means this constant will add into your VSM model, the VAR model, vector model, but it will not enter the co-integrating space. What is the co-integrating space? The pi, coefficient matrix pi, right? The unrestricted will not enter into the co-integrating space. But if you want to make it into the co-integrating space, you should make it to restricted constant. Just use here clear status. Okay, choose the unrestricted constant clear status. Set here it become a restricted constant. Okay, here it become restricted constant. And run regression, use an unrestricted system. And here we want to check the rank of the matrix pi, right? How can we check the rank of matrix pi? We have trace test and max test, right? In fact, the default setting of the PCGIF only show the trace test. Let me show you how can we conduct a trace test. After you run the regression, here also appears the test function. Use the test function. Tick this box, dynamic analysis and co-integration test. Tick this box, okay? And choose I1 co-integration analysis. Choose I1 co-integration analysis, okay? And here, show the result of trace test, okay? When you conduct a trace test or max test, you should test it. You should test null hypothesis in sequence. What does it mean? Here, if our null hypothesis is rank smaller or equal to 0, our result is significant. In other words, it rejects the null hypothesis that rank smaller or equal to 0. Our result indicates we may have one or more than one co-integrated vector. Okay, it is also our result also rejects the null hypothesis of rank smaller or equal to 1. In other words, it suggests more than one. Okay, it suggests more than one co-integrated vector. Okay, however, our result cannot reject the null hypothesis of rank smaller or equal to 2. Okay, here the result is insignificant. It can't reject the null hypothesis of rank smaller or equal to 2. Overall, our result suggests our system, this matrix, coefficient matrix pi, includes 2 co-integrated vectors. Right? Can you understand this? Okay. This result suggests we may have 2 co-integrated vectors. Okay. Someone wants to conduct max test. How can we conduct max test? Here, take notes, because our notes of a computer lab show the trace test, but the default setting only show the trace test. Our notes do not show the max test. How can we show the max test? Use a model function, but this time do not formulate the equation. Just use the option, choose the option, and repeat it again. Use the model function option, further option, okay? Tick the box, co-integration test with max test, okay? Tick this box, co-integration test with max test. Close the window, and test it again. Co-integration test, I1 co-integration analysis. Here, we get the result of both trace test and max test. Okay, here we get the result of both trace test and max test. However, obviously, the result of max test is different from the result of trace test. Okay, I should say, in a lot of situations, max test and trace test may lead to different results. Max test and trace test may lead to different results. But when you read the empirical papers, you will find recent papers tend to use trace test. In other words, when you conduct research or when you use PCGIF to address your summative assignment, you can only show the trace test. Okay, it doesn't matter. You can just use a trace test to make your conclusion. Okay. If you want to show the max test, it's also okay. I've told you how can we show the max test. Based on the trace test, our results suggest two co-integrating vectors. So we are going to construct a co-integrating vars. Okay, how can we do it? Just repeat the process, repeat the model. Just also use this model. But this step, choose co-integrated var. This step, choose co-integrated var. Our model suggests two. If you make prediction based on the trace test, our trace test suggests two co-integrating rank. Okay, so here we input 2. Okay, here we input 2. If your model suggests 1, we input 1. Okay, our model suggests 2, we input 2. Here we get the result. We get the coefficient matrix beta as well as coefficient matrix alpha. Okay, we get the 2. We also get a reduced form beta. Okay, what is a reduced form equation? Please check your lecture notes too. It makes comparison between structural form and reduced form equation. Okay, it is related to the endogenous variables. Please check your lecture notes too. But the software here shows both reduced form and structural form of the co-integrating vectors. Okay, in some situation, maybe your model suggests only one co-integrated vector. In here, you just need to choose a co-integrating rank 1. Just take it as an example. Input 1, and you will get only one co-integrated vector, right? You will only get one co-integrating vector. Okay. It also shows the matrix beta, matrix alpha, as well as reduced form beta, right? Reduced form beta. This beta is a co-integrating vector. It shows the relationship between the different variables, right? I will give back the control to you. You can do some practice, okay?